Good morning to all. Myself, Honeycomb from Aerospace Engineering Department. Today I am going to take one topic from Fundamentals of Aerospace subject. So the topic name is Development of Aircraft Structures. So in the development of aircraft structures, I am going to take the uh, topic from the DT stage. First one is empathy. So in that empathy, why safety is core needed in the aircraft structures. So in that cases, we will check the structures and we will implement the material during the manufacturing of the aircraft. If I use the very lightweight and low cost material means definitely the metal it will be damaged during the flying conditions due to the high impact force and unwanted gust it will be acting on the surface area. Next one is the types of aircraft in that structured manner. So in that aircraft, it can be classified into two types. So first one is the monocoque and semi-monocoque structures. So in that monocoque structures, the load, it can be, entire load can be carried by the skin. These type of monocoque structures nowadays it can be utilized for the all the type of aircrafts. And next one is semi-monocoque structure. So in that semi-monocoque structures, the internal frames like strings, balancing strength, and weights, it can be useful for these cases. So mostly the modern aircrafts are manufactured with the help of the semi-monocoque structures. And next one is the frame and stringers. So in that frames, it can be utilized to connect the two wings, like upper wing and lower wing. It can be connected with the help of frame and strings. And the major structures are in that cases the primary load. So in that primary loads, what are the loads it can be found during the flying conditions? First one is a tension load, compressive load, and bending load, torsion and shear load. This type of the load it can be found during the flying conditions for the unwanted gust. That means the more amount of atmospheric pressure acting on the airplane. Next one is the component roles. So here the spores, ribs, strings, skins here, aerodynamics and inertial loads. It can be useful for these component roles. And next one is redundantary. So here the multiple loads path it can be found in that area. So in that cases the failure it will be happen. So these are all the failures. It can be solved with the help of the group task. So in that group, they have developed to solve this kind of issues. And the next was the prototype stage. So in that prototype stage, the first we need to sketch the aircraft like a line diagram. So in that line diagram, so we will draw with the help of some softwares, AutoCAD. So in that software, we will draw the full fuselage with the help of monocoque or semi-monocoque structures, frames, strings. In that, it can be easy to predict the load where it happen and when will it will be fall and which location the more amount of load it can be found with the help of this software. So in that visualizing the stress concept, we will find out the in that software itself. And in that testing cases, the fatigue, generally the fatigue load, it will be happen during this condition. So what is meant by fatigue? So cyclic load, it will be acting on particular area. So for example, if you punch the one table particular area more than 1,000 times, definitely the table it will be break due to the continuous load or cyclic load fall on that particular area. So generally the metal fatigue it can be found. So to solve this issue, so if the cyclic load happened on particular area means we will rectify we will solve the load in these cases. Next one is a case study on Boeing 737. So in that Boeing 737, so we will generally we will found the loss of control, and several accidents are found the loss of control only, like radar mismatching, and control surfaces are not working, like aileron, elevator, rudder. These are all the conditions. So we will found the this type of area with the help of sensors. Advantages, if I use the composite materials, it have a more strength compared to the metal. So it have a high melting point compared to the metal. So by using the sandwich construction, it have a superior stiffness and damage tolerance. So future directions in the aircraft structural development. So developments are going like additive manufactured materials and sustainability focus on recycling materials. So these are all the materials it can be utilized to solve these issues. So thank you. So we will catch you on next topic on next week.